Welcome back to another exciting day in mathematics. Warm-up number 23, Michael Jordan's on the screen. Let's get started, please. After you're done with the warm-up, make sure you get 3 brand new graph papers. Today we're going to be doing a lot of transformations. Get started, please. All right. Check with the neighbors, see where they're at with the warm-up so you can get this show on the road. All right. Shall we? So today's Wednesday. By now we should be good with these. Let's see, 1A. I need an answer for 1A. Answer for 1A. Let's see, who haven't we called on in a while, Julian? I'm saying, who haven't we called on in a while? Oh, Renzo, what'd you get for 1A? 1A. 27. Hands, have you got 27? That is correct. And here goes the process just to make sure we got it. First of all, we need to rewrite it with the numerator being 1 on the exponent. So we write 9 to the 1/2 power, and the 3, we move it to the side, so that's times 3 on the exponent. From there, what is the 1/2 power, everyone? Half power is what? Square root. So we square root of 9, put that in parentheses, to the 3rd power. Next, bless you. What is square root of 9? Square root of 9 is 3. We still have the 3rd power there. So what is 3 to the 3rd? That's 3 times 3 times 3. What is 3 times 3? 9 times 3, that's 27. Pretty good, Renzo. Let's go. All right. Next, 1B. Check with your neighbor, see what they got, and then Renzo's going to pass it to someone. 1B. Jaime, what'd you get for 1B? Two square root 7 over 7. Let's double check that. And it looks like it's right, by the way. Let's go, Jaime. So what is on the denominator? Square root of 7. So we multiply top and bottom times square root of 7. Top and bottom times square root of 7. So we have on the numerator 2 square root of 7 over, what is 7 times 7 on the denominator? That's 49. So square root of 49. So numerator stays the same, 2 square root of 7. What is square root of 49? 7, and that's how we get that. Not bad, not bad. Let's go to number 1C. Just a reminder, perfect squared numbers are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. We're thinking about 2 factors that give us 27. One of them has to be a perfect square number. Tell your neighbor what those numbers are first. Then Jaime's going to pass them one. Go ahead, Jaime. Nine and 3. So this becomes 9 times 3. That is correct. So, which was my perfect square number? The 9, right? So, what is square root of 9? 3. So, we no longer have the 9 inside of the square root. And what's left inside of the square root? The 3. So, we're left with square root 3. And if you got that by yourself, all right, pretty good, pretty good. Let's move on. Let's go to number 2. Here goes, number 2. Let me make some space here. So once again, the format for the equation, it needs to be in the form y equals mx plus b. The top one is already in that form, and I'm going to use blue to graph that. Help me graph that one. Leo, pass someone. Who? Autumn. Where do we start for the first equation? -5. So I'm going to circle -5 and place my point at -5. There it is. And what is our slope, Autumn? 4, and in fraction form is 4/1. So that means 4 steps up, 1, 2, 3, 4, 1 to the right, plot your point, do it again, 1, 2, 3, 4, 1 to the right, plot your point, graph your line. So I'm going to graph my line, nice and straight. And arrows at the end to indicate that it keeps going. There it is. However, the second one is not in this format. So tell your neighbor what to do with the second one to make it into this format. Then Autumn's going to pass someone. Carlos, what do I do? -3/2x, very good. -3/2x. So that leaves us with y on this side, -3/2x plus 6. All right, continue, Carlos. Where do I start to graph that one? +6, I circle that. Place my point on +6. 3 down, 2 to the right. That's our slope. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Graph your line. Arrows at the end. And remind your neighbor, what is the solution to that one? What is the solution to that one? Carlos, pass it on. Miguel, what's the solution to that one? Solution 2, 3, Michael Jordan. Or in other words, where the lines intersect. All right, we good? All right, move on. That's number 2. Number 3. Turn to your neighbor, let them know what you got for number 3. Number 3. All right, pass someone, Miguel. Who? Julian, answer. Oh, you're going to help me with the process? Okay, check f of x to y, very good. 5x squared minus 3, next. Let's do the process. You already started it, so. Plus 3. Be nice, people. Y plus 3 equals 5 square root, x squared, sorry. Go. You what? Divide by 5, divide by 5. So we end up with y plus 3 divided by 5 equals x squared. Next. Square root to both sides. This cancels that. We're left with square root of y plus 3 over 5 equals x. Next. You flip the x and the y. So I'm going to go over here to show that one. That is square root of x plus 3 over 5 equals y. And then f of x with a little -1 for the inverse. Hands, if you got that by yourself? All right, not bad, not bad. Let's go to number 4. That one. Show your neighbor what you got, and then Julian's going to pass them one. Number 4. All right, Julian, pass them one. Allison, do you have an answer, or you're going to walk us through the process? You have what? Oh, so you're going to help us with the process? All right, good. So here we go. What is 1/2? Square root. Very good. So we write square root of x plus 10 equals to 7. Next. How do we cancel the square root? Square to both sides. This cancels that. We're left with x plus 10 equals 49. And last but not least, subtract 10 from each side. X equals 39. Hands if you got that by yourself. All right, good. Looks like everybody's on the ball. All right, send me your warm-up, please. There's the code. And get a Cornell note ready, please. All right, send that in, and here's the agenda. Warm-up number 23 is done. We're in the middle of transformation of functions, and tonight's home plate, 5 transformations only. Notice the word only. Makes it sound very little, right? Only. So when you go buy a car, your monthly payments are only $650. What? That's not including gas? No. Or insurance? What? Okay, we good? All right, to access the home play, here's the code. Write this down. 3ARV5. 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 All right. So last night's home play is that one. Get that out. Show your neighbor what you did really quick before we submit it on Nearpod. All right. So last night's home play was that. So on your screen, send me a picture, please, so we can move on. Quick picture of what you did. This one's not going in Canvas. This is just going here in Nearpod as participation. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you. Tonight's home play looks like this. You're like, oh snap. Oh snap is right. Or should I say, oh snap? How about that? All right. So with that said, I can transform a function using different parameters. For today, let's do this. Instead of a blank sheet of paper, write the objective at the bottom left of your graph paper. Bottom left of your graph paper, because we're going to be graphing a lot. You're like, what left, Mr. Q? Doesn't matter. Just write it on the graph paper somewhere. I can transform a function using different parameters. By now, we are experts at what functions are. Is that correct? If I was to ask you for an example, you know what to do, yeah? All right, so we don't need that because you already have the notes for functions. And we filled out our Freyer model. Once again, our main concept is functions. We're in the middle of transformations, and we're using different parameters. Remind your neighbor, what are the 3 parameters that we've been using so far for transformations? Remind your neighbor. 3 different parameters. What are they? Three different parameters. All right, good conversations. Looks like Michelle's got it. Very good, Michelle. I see you. We got Jacob in the front's got it. Very good, Jacob. I see you. Yaretzi's got it. But let's go with Natalia Castro. What are the three parameters that we've been working with? Give us three letters. What are they? A, yes. What other? H and K. That is correct. Natalia from the corner. Let's continue. So we know what functions are. We went with the three parameters A, H, and K. We wrapped that one up yesterday. So on your graph paper, copy this one on the top left. Write that down. Example Q. It reads, graph f of x equals x squared. Write the whole thing. I'm going to give you time so you can write the whole thing on the top left. Copy it as it is, and I'm going to use green for the transformation of a equals 2, h equals 3, and k equals -5. Copy that first. All right. Here we go. It says, graph f of x equals x squared. By now we know how to graph that without a table. Remind your neighbor how to graph this without a table. I'm going to do that one in black, How do we graph that without a table? Remind your neighbor. All right, so as soon as, here goes the process. I'm going to do a think aloud. Does everybody know what that is? No, Mr. Q. That means I'm going to be talking what I'm wanting to think. Here goes. Mr. Q, the first thing that I see when I hear graph, I focus my attention to -2, -1, 0, 1, and 2 of x. That's my attention. So therefore, I start with -2. What is -2 squared? -2 squared is +4. Plot your points. Next, what is the next value? -1. What is -1 squared? 1. Next, what is 0 squared? 0. 1 squared, 1. 2 squared, 4. And we label that f of x. Next, they say, given this form, write the new transformed function. So look up. I'm going to use this, but I'm going to rewrite it down here with blanks instead of A, H, and K. So I'm going to write g of x equals blank times f x minus blank plus blank. Are we there so far? All right, so what is the first value? A. What is that value here according to what they give us? 2, so write 2 there. What is H? H is +3. And what is K? -5. So let's rewrite this. Here we go. G of x equals 2 f of x minus 3. Now don't forget outside of the parentheses, this is a what kind of function? A quadratic. So you write the squared. And then negative times the positive is -5. All right. So now that we have our transformation, Tell your neighbor where we're going to move these 5 points at the end. Where are we going to move them at the end? Tell your neighbor in what direction. All right, Natalia Castro, pass them one. Julian. Down 5, and then 3 to the right. However, before we do those steps, tell your neighbor, I'm going to use red, circle this one in red, tell your neighbor what that's going to do to these points. All right, so I'm going to zoom in. Remember, A is 2. So let me zoom in so we can plot some new points. Here it goes. Start with -2, 4. -2, 4 is right here. But since A is 2, so now the new point is going to be at -2 what? All right, let's do it again. Our original point is at -2, 4. Is that correct? But if our A is 2, so our new point is going to be at -2 instead of 4, it's going to be at 8. So plot your red point up here. Next point. Our original point is at -1, 1. But since A is 2, so now it's -1, 2. 0, 0. 1, 2, and 2, 8. Now notice, I don't connect them here because I'm not done. Where did Julian said we're going to move this to? 3 to the right and 5 down. So I'm going to start with the farthest red point. I'm going to switch to green now. I'm going to go 1, 2, 3, 1, 2, 3, 4, 5. Let's do it again with the other point. 1, 2, 3, 1, 2, 3, 4, 5. So here are my 2 points that are on top. Let's go with these now. 1, 2, 3, 1, 2, 3, 4, 5. This one, 1, 2, 3, 1, 2, 3, 4, 5. And then this one, 1, 2, 3, 1, 2, 3, 4, 5. And now we connect them. Arrows at the end. And we label that what? G of x. That's our final transformation. So as you're finishing up, here goes the process one more time. Look up. They told us to graph that. What numbers did I think of first? -2, -1, 0, 1, and 2 of x. And I squared them to get my 5 points. I label that f of x. Next, I wrote this, but with blanks for A, H, and K right here. Substituted the values, simplified, and rewrote it, including the exponents. From there, I asked Julian where it was going. He said 3 to the right, 5 down, but he said we're going to do that at the end, and we saw the multiply being 2, so we can stretch the points. Once we got our points stretched, we moved it, and there it is. From 1 to 5, I'll come to borrow you with it so far. Where are we at? 5, 5, 4s, 5, 4s, 3s. Okay. Send me your notes, please. Here it goes. Let me send you the screen. All right. Thank you for sending that in. Here goes. Let's go to the next one. Go to the next coordinate plane. Let's do it again. Copy this one. It says, example super Q, graph f of x equals x squared, given g of x equals a times f of x minus h plus k. Write the new transform function given a equals 1/2 h equals -4, and k equals 3, then graph the transformation. Copy that first. I'll give you some time. All right. All right, so let's graph f of x equals x squared. Once again, remind your neighbor how to do that without a table. How do you graph f of x equals x squared? Remind them, please. Should go a little bit faster by now. I'm going to do that in black, and Yaretsi is going to guide us through that. Once again, remind your neighbor, how do you graph that without a table? All right, go ahead, Yaretsi. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And we label that f of x. Next, we rewrite this one down here, but with blanks. G of x equals blank times f, x minus blank squared blank, or plus blank. Bless you. What is A? A is 1/2. What is H? -4. And what is K? 3. So far, so good? All right, let's simplify that. So my new transformation is g of x 1/2 f x. Now pay attention to this part. Look up. What is -4 times the negative that's already in there? +4 squared plus 3. So before we move on, tell your neighbor where we're going to move the points at the end. Where are we moving the points at the end? And Yaretsi is going to pass someone. Where are we moving the points at the end? Tell your neighbor. Yaretsi, pass someone. Sarah? 3 up. To the left. Hands, have you got that so far? Okay. However, we need to do either the stretch or compress. So looking at this, is it going to stretch it or compress it? Guys, according to the 1/2, is it going to stretch the points or compress them? Compress, because it's a fraction. So here we go. Our original was -2, 4. However, since we're going to cut it in half, it's going to be at -2 what? Instead of -2, 4, it becomes -2 what? 2. That is correct, because half of 4 is 2. Next one, -1, 1. But if we cut it in half, it's -1, what? 1/2. That is correct, right there. 0, 0, and then they just reflect up to the other side. 1/2 and 2. So instead of connecting those points, those are the points that we're going to move in which direction? 4 to the left and 3 up. So let's do that. This one, 4 to the left. 1, 2, 3, 4. 1, 2, 3. This one, 1, 2, 3, 4. 1, 2, 3. This one, I'm going by halves. 1, 2, 3, 4. 1, 2, 3. This one, 1, 2, 3, 4. 1, 2, 3. And this one, 1, 2, 3, 4. 1, 2, 3. Now we connect them. And we label that g of x. Did it compress it? Yes, because it's a fraction. Very good. All right, let me send you the screen so you can send me your notes. All right, copy that one in the new graph. New graph. And it reads, example omega cubed, right? Graph f of x equals x squared, then graph g of x equals f, parentheses x minus 2 plus 3 over 2. You're like, Mr. Q, that looks different. I know. That's why I'm bringing it in. All right, turn to your neighbor, let them know how to graph f of x equals x squared. By now, they should be experts at that. Then graph it. All right? All right, who went last? Who? Sarah, pass someone? Autumn. Let's graph this one. Tell me what to do. 0, 0. Negative 1, 1. Negative 2, 4. 2, 4. 1, 1. Okay, let's label that. F of x. So, look up. It says, then graph according to that. Doesn't this look kind of weird, guys? But we can rewrite it. Look up. I'm going to zoom in. Here it goes. Whenever you get something like this, first thing I want you to do is you're going to place a 1 next to the f. Then, I want you to box that 1 with a denominator, like so. So if the 1 is in the numerator, the 2 is in the denominator, what kind of fraction do we have? What kind of fraction do you see? If 1 is in the numerator, 2 in the denominator, 1/2. Does everybody see that? And what do we have left? We have f of x minus 2. This is a quadratic, so you write the squared plus 3, and all that equal to g of x. You guys see the only thing to do with these? Yes? So, now that we have that, turn to your neighbor, let them know where we're going to move the points at the end. Where do we move the points at the end? I'm going to use red for the end. All right? Who went last? Pass someone? Go up 3. And then right 2. Hands if you got that. All right, but before that, circle the 1/2 in blue so we can either stretch or compress. What's going to happen to these? Stretch or compress? Yeah, compress. So therefore, negative 2, 4 becomes what? Negative 2, 2. Yeah, because it's cut in half. Next one, negative 1, 1 becomes negative 1, 1/2. 0, 0. And then you just reflect those on the other side. 1/2 and 2, 2. And lastly, we're going to move them 2 to the right and 3 up. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. These in half. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And the last one, 1, 2, 1, 2, 3. And we label that g of x. From 1 to 5, I'll come to where you with that. Where are we at? 3, 4, 5, 4, 5, okay. Let me send you the screen so you can see the graph. It reads, graph f of x equals x cubed, given g of x equals a f x minus h plus k. Write the new transform function when a is 1/4, h is 5, and k is 3. Then graph the transformation. All right, for the sake of time, I'm going to have someone help me with this one. Let's go with Carlos. Before Carlos tells me, tell your neighbor what to do to graph this one without a table. How do we graph f of x equals x cubed without a table? Zero, zero. Hold on, let me zoom in. So let me start at -2. What do I do with -2? -2 times -2 times -2, which equals to -8. How about -1? -1. How about 1? +1. How about 2? 2 +8. That is correct. I'm sure you make those points a little bit bigger so you can see them, because we need to either stretch them or compress them. All right, let me zoom out, and we label that f of x. Then what do? We rewrite this one with blanks. G of x equals blank times f x minus blank cubed plus blank. So they give us 1/4. They give us h is 5 and k is 3. So my new transformation is g of x equals 1/4 f x minus 5 cubed plus 3. Where's that going to, Carlos? Right 5, up 3. But before we do that, I'm going to circle it in green. What does that do to the whole thing, everyone? It compresses it, yes? All right, so let me zoom in just to make sure we got it. Well, I'm not going to zoom in, but here we go. So look up. I'm going to start with 2, 8. 2, 8. But it's going to compress by 1/4. So what is 8 times 1/4? That's 8/4, which is what? 2. So 2, 8 becomes 2, 2. Everybody see that? Yes? And so on and so forth. I'm going to stop right there. Those of you following on YouTube, make sure you get some practice in. I'll see you guys next time. Peace.